Hey everyone, thanks for watching today's video where we're going to talk about the mid-segments of triangles. So just to kind of explain what it is, the mid-segment of a triangle is the segment connecting two midpoints of two sides of a triangle. And the best way to kind of figure out what that means is to look at the example. And also let's touch on the mid-segment theorem really quick. So the theorem says that the mid-segment of a line is parallel to the third side of the triangle and half the length of the third side. So after reading those two things, it can probably be pretty confusing, so let's figure out what we're actually saying. So the mid-segment of a triangle is a segment connecting the two midpoints of the other two sides. So here we have side BC, that's this one right here, and we have side AB, right, of the bigger triangle ABC, and we're saying that we're connecting their midpoints. So E is the midpoint of CB, I write that here, and then also we have D is the midpoint of AB, so that's there. And what the mid-segment is the segment that connects them. So that's this one right here. It connects point D to point E. Then now let's talk about the theorem. Well, the theorem says that the mid-segment will be parallel to the third side. So the third side is kind of like this would be the first side, even though it's not much of a side. The middle one would be the second, and the bottom one would be the third. So it's this is parallel to this. Okay. So we get that part, and then what it means is that it also says that the mid-segment will be half the length of this one, of the third side. So segment AC, well, I'll just write this here. So the length of DE, so DE equals 1/2 of AC. So DE is half the length of AC, or another way to say that is AC is twice the length of DE. So that's the same as writing 2DE, 2 times DE equals AC. And that's what the mid-segment theorem says, and that's what mid-segments are. So now the best way to do it, obviously, is to look at some examples. So given that D and E are the midpoints, so this is that example we were looking at earlier, find the length of segment AC. Well, now we're going to plug it into that formula we just talked about where we said DE equals 1/2 times the measurement of AC. Well, I know that DE is 8, so I'm going to say 8 equals 1/2 times AC. Multiply both sides by 2, that'll get rid of the denominator there, and I'll get 16 equals 1 AC, but I can just write that as AC. So the measurement of angle AC of segment AC is 16. And the quickest way to do it is just take the mid-segment, multiply it by 2, and you'll get to the 16. So that's what we're doing here. And now we have a much tougher example that I want to look at here. And this one will kind of really make sure if you understand the concepts. So this is what we're given. ABC is a right triangle, so that's the bigger triangle here. And it's right, that's why we have this symbol right there. Okay, so D, E, and F are midpoints. So D, E, and F are all midpoints. That means this must be congruent to this. This side must be congruent to this side. And this must be congruent to this. That's what definition of midpoint is. It breaks into two congruent segments. Okay, now it says AB is 24. So I'm going to label that. Whenever I get things like this, I always want to label. So I know AB is 24. I know BC is 10. So BC, B to C, that's right there. That is going to be 10. Find the perimeter of triangle DEF. So what I want is I want this side plus this side plus this side. I want the perimeter of that inside triangle. Sorry about that, I erased that one on accident. So how am I going to figure that out? Well, this is a really good question. I recommend you pause the video if you want to and try to figure this out on your own before I do it. So if I want to know the perimeter of the little triangle, first I have to figure out the perimeter or all three sides of the larger triangle, because the mid-segment theorem tells me a little bit of this information that's actually going to help. So let's take a look at the outside triangle. So this is the outside triangle, and let's look at one mid-segment at a time. So if I know D and E, so D and E is right here. Well, my mid-segment theorem says that this length, that one right there, is going to be half as big as the bottom one there. If the bottom one is 10, that one must be 5. So DE equals 5. And that's due to the mid-segment theorem. If you kind of like, it looks really confusing because we have a lot of stuff going on, and that's what I wanted. It wanted it to be tough. But if you see that we just have DE and then BC, we can see that DE is the mid-segment of BC. So DE must be half the length of BC, which is 5. And then now we can do a similar thing here with AB. AB's mid-segment is EF. So EF must equal half of segment AB. Well, that must be what? Well, it's got to be 12. Okay, so now I have two of the sides I want. I know that this is 5. I know that this side right here is 12. Okay, so that looks good to me. We're getting started. Okay, now I only have one side left. And if that's a right triangle, then this must be a right triangle because of with mid-segments, there has to be. So now we have a right triangle here, and if we have a right triangle, then we can do the Pythagorean theorem, right? So we have a squared plus b squared equals c squared. So this is really combining a lot of things. So if a squared, we could make that, those are the legs, a and b are the legs, so that's 5 squared plus 12 squared equals c squared. And this is actually one of the Pythagorean triples we talked about way back in the course. So 5 squared is 25 plus 12 squared is 144 equals c squared. That's 169 equals c squared. To find c, I'm going to take the square root of both sides, and I get that c is 13 units. So that's not the answer to the question. That's actually just the length of the side. And instead of saying c equals 13, I'll write that here. But now let's think about what that means in side lengths. That's df. So side length df is 13. And why did I do all that? Why is that important? Well, it's the actual question which says find the perimeter of triangle DEF. Well, it's going to be 5 plus 12 plus 13 because the area around that. So P equals 5 plus 12 plus 13. That's going to be 17 plus 13 should be 30. Okay, and now I want to talk about really quickly another way that you could have solved this. So you could see that DF, this segment right here, DF, is going to be the mid-segment of AC, the outer two. So that's this one and then this one here, the two diagonal segments. So what you could do is you could find the length of the outer diagonal, and then that would give you the length of the inner diagonal because you know it has to be half that size. And how would we find the length of the outer diagonal? Well, we would use the Pythagorean theorem. We would say 10 squared plus 24 squared equals c squared. And if we did that, that's actually our Pythagorean triple multiplied by 2, so we would get c equals 26. So we know that AC must be 26. This whole distance is 26. We would divide by 2 and we would get 13 there, and it would be the same answer. So that's another way you can do it. I prefer the way I did it here, where we kind of just get the two easy sides. The one we use what they give us, we get the two easy sides. Then we use the Pythagorean theorem on the smaller triangle. That's the way that makes most sense to me. But if you want to do it that other way, using the mid-segment theorem on all three sides, that is also an option. Just wanted to throw that out there as a way to do it. So the perimeter is 30. Hopefully that makes sense. If you can do this example, you have a good grasp on mid-segments and the Pythagorean theorem, and you're doing really well. So don't hesitate to contact me with any questions. Have a good one.